Okay, so we've looked at vectors geometrically. Now let's look at them algebraically. So let's look at a definition first. The definition is with respect to a position vector. So let's read. If v equals, and notice this notation, okay, it represents the vector, is an algebraic vector whose initial point is at the origin, then v is called a position vector. Okay, so a position vector has the initial point at the origin on your xy axis scale or xy axis grid system. Are you with me? Okay, but not all vectors have the initial point at the origin. So not all vectors have or are called a position vector. This theorem will help us turn vectors into position vectors. Okay? So let's take a look at the theorem. Suppose that v is a vector with an initial point p sub 1, which is the point x sub 1, y sub 1. But it's not necessarily at the origin. So the initial point is not necessarily at the origin. And now it also has a terminal point p sub 2, x sub 2, y sub 2. Okay, if we have vector v, which starts at p sub 1 and goes to p sub 2, we've seen this notation, we know this notation, then v is equal to the position vector. So here's how you find the position vector. You are going to subtract the x's and the y's. Now the order is very important. To find the position vector, you're always going to take the terminal point and minus the initial point. So I'm going to take x sub 2 and minus x sub 1 to find the x component, and y sub 2 minus y sub 1 to find the y component. Okay, this is how I get it back to a position vector. By the way, this can also be rewritten in this format also. And you're like, where are those i's and j's? What do those mean? I denotes a unit vector whose direction is along the positive x-axis, whereas j denotes a unit vector whose direction is along the positive y-axis. So the I is a horizontal component and the j is a vertical component for vectors. Remember how we were counting before? We said, oh, 5 units up, 2 units to the right. Well, it has a horizontal and a vertical component, the I and the j. So that was all, before this was all geometrically. Now this is all algebraically, and so we have different notations for the algebra. I represents the horizontal, so it was 2 units to the right, and j is the vertical, it was 5 units up. Cool? Okay, so hang in there. We are going to find some position vectors. Okay, so let's look at these directions. They want us to find the position vector. So remember, the position vector actually has the initial point at the origin. Okay? So let's take a look at problem number 1. P is going to be, in all of these problems, P is the initial point, Q is the terminal point. So to find the position vector, that vector V is going to be found by us taking the terminal x, 7, minus the initial x of 0, comma, the 9, which is the terminal y, minus the initial y, which is 0, which actually gives me the position vector 7, 9. So interestingly enough, on number 1, P is the initial vector, which actually meant that when I graph this, this was already starting at the origin, and I would go to the point 7, 9. So this would have been the position vector, starting at the origin and ending at the point 7, 9, which is what this one already did. So we already had the position vector. Now, remember the other way of writing it. This could be 7i plus 9j, which means it has a horizontal component of 7 and a vertical component of 9. So here we are at 7, 9. Are you with me? Okay. Or I should say point. Cool? Okay, so let's look at number 2. Number 2 clearly does not have the initial point being at the origin. So let's find this. To find my position vector, I'm going to take the terminal x, which is 9, minus the initial x, which is -1, the terminal y, -10, minus the initial y of -7, which would give me 10 and, what is that, -3? Cool. Which means it also could be written as 10i minus 3j. Are y'all with me on this? Okay, so remember, that will give me my position vector. This will start at the origin. The position vector would start at the origin. Currently, on this problem, this is number 2, if I draw this out, we start at -1 and -7. There's the point P, 9 and -10. There's the point Q. This is where this is drawn at. The position vector says now we're going to be at 10, -3. So we'll start at the origin. Instead of the vector being here, we're going to start at the origin. And now we're going to go 10 units on the horizontal and 3 units down. So this is where my position vector would be, right here, versus down here. This is what this does. Problem number 2 is a better example of what really is happening. Here was the original vector given these 2 points, but the position vector became 10 and -3. Cool? Okay, so it shifted it up and to the origin. Got it? Okay, so let's look at problem number 3 here. See if you follow along. The position vector, what number am I taking? Yeah, this x of 7 minus 1, and then this y of 7 minus the 3, which is going to give me 6, 4 on the position vector. Or it could be written as 6i plus 4j. 6 on the horizontal, 4 on the vertical. Just like here we had 10 on the horizontal and 3 negative on the vertical. Good? Okay, last problem. Position vector. Let's see if you follow along. 0 minus the 2 and 5 minus the 0, which would give me -2 and a +5 for my position vector. Cool? Okay, so position vectors are actually quite simple. You're actually taking the original vector and you are moving it so its initial point is now at the origin. That's all the position vectors are trying to do. Hang in there. Got some properties for us to go over. Okay, so let's look over here on the left side of the board. We're looking at the definition of algebra for vectors. Remember when they talk about algebra, you're adding, you're subtracting, you're multiplying, you're dividing. Anytime we get like new types of numbers, we have to learn how to add, subtract, and multiply them all over again, as well as divide them. So let's take a look. We have 2 vectors. Vector V has the components A and B. Vector W has the components C and D. And alpha is a scalar. It's a real number. If you want to add the 2 vectors, then you're going to add the x components and the y components together. Okay, or the components in the horizontal direction and the components in the vertical direction. Got it? And if you're going to subtract them, be careful when you add and subtract them. V comes first. V comes first because that's how they wrote it. You're not finding the position vector. The position vector makes you flip it around. That's not what we're doing. We're just adding a couple of vectors together algebraically versus geometrically like we were doing a while ago. So I'm going to subtract those x components and those y components, those horizontal and those vertical components. If I'm multiplying by the scalar alpha, then that's just going to get multiplied in there. Got it? Now this last one, these double lines on either side of v represent this formula, the square root of a squared plus b squared. And this formula represents the magnitude of vector v. Remember what magnitude represents. What does it represent? Yeah, it represents the length of vector v. So this formula right here helps you find the length of vector v by taking the square root of a squared plus b squared. Almost seems like Pythagorean's theorem, doesn't it? Okay. Got this last part? This represents the magnitude of vector v. This helps me find it, the length of it. So now I've got some properties over here on the right side of the board that deal with this magnitude of vector v. So notice, if v is a vector and alpha is a scalar, then the magnitude of vector v, because that's what those double lines around the v mean, the magnitude of vector v has to be greater than or equal to 0. So in other words, it has to be positive, because length is positive, isn't it? Good. Let's look at the second property. The magnitude of vector v equals 0 if and only if, you've seen me use this before, this IFF means if and only if, the magnitude of vector v actually equals 0 if and only if v is the 0 vector. Makes sense, right? Property 3, the magnitude of negative v, remember that negative means it's going in the opposite direction, right? So the magnitude of the negative v is equal to the magnitude of positive v. It just changed direction on us, but the length is the same. Good? Okay. Property 4, if you're taking the magnitude of this scalar times v, it would be the same as taking the magnitude of vector v and multiplying it by the absolute value of that scalar number. And last but not least, if the magnitude of vector v equals 1, then this is called a unit vector. Cool? Okay, so hang in. Okay, so let's look at some examples that apply to those properties of vectors that we just looked at, as well as those algebra of vectors. So let's look at the first one. So when I look at the first one, it says find, and remember the double lines around the v means magnitude. They want you to find the length, the magnitude of this vector. And the vector they gave us was 10i minus 24j. So first things first, remember the formula. The formula says to find the magnitude, it's equal to the square root of a squared plus b squared. A squared is the horizontal, the first one. B is the vertical component, the second one. So when I write this, it's going to look like the square root of 10 squared plus negative 24 squared, which square root of 100 plus, I heard it, 576, which equals the square root of 676, and you're on your calculators. So the magnitude of v is 26. So that's the length of v. Good? Cool. Keep it simple because that's how simple this is. All right, let's look at number 2. So number 2 wants me to find the magnitude of negative 5v. Now, if you remember from the properties that we discussed just a little bit ago, negative 5 is a number, right? It's a scalar, yes? Which actually means, based upon one of those properties, it means I can actually take the absolute value of that scalar and multiply it by the magnitude of the vector. Good? Okay. Well, you know the absolute value of negative 5. What is it? 5. And based upon the problem, the magnitude of the vector is 8. So, the magnitude of negative 5v would be equal to 40. The length of this negative 5v is equal to 40. Cool? Okay, hang in there. Got a couple more examples for us. Okay, so let's look at a couple more examples. Let's look at number 3. They said find 5v plus 3w given vector v is equal to this and vector w is equal to that. Okay, so let's not think too deep about this, shall we? I know we have those algebra on vectors components that I gave you, what it looks like when you add a couple of vectors, subtract them, etc. Let's not overthink this. This is asking us to find 5v plus 3w. Well, this is 5 times v and 3 times w, yes? Okay, well, don't we know v? Yeah, we know v. So I'm going to do 5 times 5i minus 5j. And don't I know w? Cool. Plus 3 times negative 4i plus 3j. And now it's just a distribution problem, right? Excellent. As I said, let's not overthink this too much. Okay, just because we're dealing with vectors doesn't mean that the process that I'm doing, which we have done almost forever and a day, is going to change. So I'm going to collect like terms. I'm going to combine these i's. So I get 13i, and then I'm going to combine the j's, and I get 16j. Cool? Excellent. Good on that? Cool. As I said, please don't overthink this process. Even the last two problems, don't overthink them. Now let's look at this one. They're asking us to find the magnitude of v minus w. Remember, those double lines around means magnitude. Well, that means I need to find the length, right? I'm trying to find the length of what? V minus w. So what do you think we're going to have to figure out first? Excellent. V minus w. So here's something to consider. These double lines, which mean magnitude, almost act like parentheses, which means I have to do what's inside the parentheses first, right? Okay, so here's the deal. First things first. First, find v minus w. So, v is 5i minus 6j, and I'm going to subtract w, which is 6i minus 3j. And yes, you should put them in parentheses, especially with subtraction. Why? See what's going to happen with the second parenthesis? Yeah, so I got 5i minus 6j, and this becomes a negative 6i and a positive 3j. Agreed? Combining like terms, we get negative I, and we get a negative 3j. Agreed? Awesome. So now, here's the deal. We're actually finding, let's think about this. We're actually finding the magnitude of negative I minus 3j. Okay, so just like that other problem we did prior to this, you're going to take the square root of, what's your first number? Good, negative 1. So negative 1 squared. Plus, what's your second number? Good, negative 3 squared. Which equals 1 plus 9, which means we have a magnitude of the square root of 10. And unless they tell me that they want a decimal, that's the way I'm leaving it. So far, so good? Keep it simple with these. It's not as complicated as we might think just because we're dealing with vectors. They still have the same algebraic maneuvers. Hang in there. Got 2 more examples. Okay, so let's look at these 2 examples. Let's look at number 5. They're asking me to find the magnitude of vector v minus the magnitude of vector w. And here's vector v and vector w. So what do you think you have to find first? Yeah, first you got to find the magnitude of vector v and the magnitude of vector w. And then you can subtract. Agreed? Okay, so first? I need the magnitude of vector v. Well, square root of the negative 4 squared plus 5 squared, which equals the square root of 16 plus 25. So the magnitude of vector v is equal to the square root of 41, isn't it? Good. And, yep, I need the magnitude of vector w. So magnitude of vector w is the square root of 6 squared plus negative 6 squared. Okay, so I know you guys are ahead of me because you're already working on this. You're like, I see what we're doing, which is the square root of 72, which can be simplified to 6 square root of 2. Correct? Okay, so here's what this means. This means that when I do this subtraction, that the magnitude of vector v minus the magnitude of vector w will be equal to the square root of 41 minus 6 square root of 2. And unless they want a decimal, that's the way I'm going to leave it. Good? Okay, hopefully this made sense. Let's look at this next one. Number 6. They want me to find x such that the magnitude of the sum of v plus w equals 3. And here's v and here's w. So, notice what they gave me. They gave me that the magnitude, right? So here's what they've given me. I'm going to look at the fact that I have the magnitude of v plus w supposed to be equaling to 3. Well, I guess I have to add v plus w first, don't I? Okay, so I'm going to add the i's together, and then I'm going to add the j's together, right? Well, when I add the i's, I get 4 plus x, don't I? And then when we add the j's, we get plus 1j. Agreed? So, and I'm going to get rid of this 1 because I know from my standpoint it looks funny. So from your standpoint, I'm sure it also looks funny. Okay, makes sense? And now I'm supposed to find the magnitude. Well, if I'm supposed to find the magnitude of the left side, that means I'm going to deal with the square root of the first coefficient, shall I say, or component. So that quantity 4 plus x is squared plus the 1 squared equals 3. I don't know about you, but I don't like that square root there. Now this is just algebra if you think about it. This is just algebra, isn't it? Okay, so I should have put second so we knew what we were doing. So secondly, now I've got this set up. I'm just solving for x. So I need to get rid of the square root, which means what are you going to do? Yeah, you're just going to square both sides. And when you square both sides, on the other side you get a 9, right? Remember, at this point it's nothing but algebra. So you guys may be already ahead of me on this, but I'm just going to walk myself through it in case some of you are like, I'm not jumping ahead of you. So I'm going to square this parenthesis. So I'm assuming you remember how to square this. You've got to write this parenthesis out twice. And then do your distribution. Remember that. That's how you take care of this parenthesis squared. So I'm going to get 16 plus 8x plus x squared plus 1 equals 9. I see this square here. This square, this x squared, tells me I'm going to have to factor in order to solve this, which means I need it equal to 0. Excellent. So I'm going to bring everything to the left side. Why? Because my x squared is positive on the left and I want to keep it positive. So I'm going to get x squared plus 8x. So let's see. 1 and 16 is 17. But then I'm going to minus the 9, right? So that's right. That's plus, there it is. I heard you. 8 equals 0. Okay. Is that going to factor? Yeah. I'm not seeing it factoring either. Well, that's a bummer. So how are we going to solve this second degree equation if it won't factor? Yep, I heard some of you. Got to go to the quadratic formula, don't you? Yay! Do you remember your quadratic formula? I hope you do. I'll give you a few moments to write it down while I'm erasing this board, because I need time to erase this board and get myself some space, and you need to remember the quadratic formula. And some of you are like, oh man, I'm going to go look it up. So go look it up if you need to. If it's not right at the top of your head, then go look it up. Because I'm expecting you have it, because I'm not going to write the formula on the board. I'm going to be honest with you. Okay. I'm solving for x, aren't I? So, use the quadratic formula. So, x is going to equal negative b, so the negative 8, plus or minus the square root of b, which is this positive 8, squared, minus 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. Good. Okay. So, x equals negative 8 plus or minus 8 squared, 64, minus the 32, all over 2. Agreed? Okay. X equals negative 8 plus or minus the square root of, good, 32 over 2. And yes, I'm assuming you remember how to find the square root of 32. And you're like, no, okay. Isn't the square root of 32 the square root of 16 times 2? Right? So, x equals negative 8 plus or minus, yeah, 4 square root of 2, all divided by 2. Remember, if they don't ask me for a decimal, you can't go there. Okay. What I am noticing is I can factor out of the numerator a 2. And you're like, why would you want to do that? Because I want to cancel the 2 out of the denominator. So now the 2's in from the numerator and denominator cancel, which leaves me 2 answers, doesn't it? It leaves me one answer of x equaling negative 4 plus 2 square root of 2. And the other answer is x equals negative 4 minus 2 square root of 2. And they did not give me any restrictions on x. They didn't say x had to be a positive number or a negative number. So, both those answers are going to be allowed at this point, and if they don't want a decimal, then I need to leave it in that format. Cool? Awesome. So hang in there. We're going to talk about those units. Okay, so let's move on. There's a lot going on this board, so just stick with me. Let's talk about the definition of a unit vector in the direction of v. It starts off saying, for any non-zero vector v, the vector, and notice they're calling the vector u, and to find u, you're going to take the vector v and divide it by its magnitude. When you do this, u is called the unit vector that has the same direction as vector v. Got it? Okay. So again, v is any non-zero vector. If you want to find the unit vector that goes in the same direction as v, then you are going to take the vector v and divide it by its magnitude. Cool? All right, now, let's look at this second part down here. Given its magnitude and direction, you can convert the above formula. So if I multiply both sides by the magnitude of v, couldn't I find the vector v by taking its magnitude and multiplying by u? This is just an algebraic maneuver, right? If I multiply both sides by this is just an algebraic maneuver. Agreed? So we're right here. Now, Before we go any further, I want to direct you to this drawing over here. So, this drawing has the x-axis and the y-axis. It has, not the full circle because I didn't draw all the quadrants, but it has this circle right here, and the circle is of unit 1. Got it? So I've got a unit circle, don't I? Okay. And as we discussed before, the I component is the horizontal, which is in the direction of x. The j component is the vertical, it's in the direction of the y. And I have this vector v right here. The unit vector is in the same direction as the original vector v. Got it? Okay. Now, this point right here would be the point xy. Where the unit vector actually touches the unit circle would be the point xy, wouldn't it? Okay, so go back to your trig. If you remember from trig, when you're on the unit circle, the cosine of your angle is x over r, right? But if it's the unit circle, r is equal to 1, which means the cosine of the angle is just x. And the sine of the angle is just y, isn't it? So instead of saying xy, I could say cosine of alpha times sine of alpha, because there's my angle. With me? Okay, so back it up. So if I multiply both sides by the magnitude of v, I get v equals the magnitude of v times the unit vector. Well, this unit vector can be rewritten as xi, right? I is in the direction of x, so xi plus yj, and it's a 1 in front, right? Because it's a unit. But because it is a unit circle, I can replace the x with the cosine of the angle, and I can replace the y with the sine of the angle. And this angle, and alpha, which is the angle, is in between the vector and the positive side of the x-axis. So this is where your angle would need to be. Between the vector, wherever the vector is, and the positive side of the x-axis. Which, when we dealt with trig, isn't that the standard position of an angle? We'd start at the positive side of the x-axis and either go counterclockwise or clockwise, right? Okay. So, take a moment, pause this, get stuff copied, look at this drawing, make sure you understand it, and we're going to start going over a couple of examples. I'll be right back. Okay, so let's look at some examples. Let's look at these set of directions over here. It says find a unit vector in the same direction. So they gave me vector v, and from just a few minutes ago, to find the unit vector, I need to take, that's use the unit vector, the vector divided by its magnitude. Agreed? Well, the vector here is 4i. And to find its magnitude, you just got the square root of 4 squared, because the second, the j component is 0, isn't it? Which means you would have 4i divided by 4, which means in this case, your unit vector would just be I, wouldn't it? Okay? That one was nice and simple. Let's look at the second one. Same directions. Find the unit vector in the same direction as v. So, to take care of this one, same thing. I'm going to have to take the original vector v, and I'm going to have to divide it by its magnitude, because that's the formula. Well, this one has both I and j as non-zero. So we have 8i minus 6j, and now I've got to figure out the denominator, don't I? Well, 8 squared, good, 64. Negative 6 squared, good, plus 36. So what is 64 plus 36? Good. 100, which is a perfect square, which gives me 10. Now, let's reduce it. And by the way, I made a goof over here. Did you guys catch it? Some of you did. You're like, hey, you wrote down. You're right, I wrote down the wrong thing because I'm trying to find the unit vector, so that should have been a u. So my unit vector in this case, it's 8i over 10. Can't that reduce? Good. 4i over 5. 6j over 10. That can reduce. So here is my unit vector in the same direction as the original vector. Cool? Awesome. Okay, let's look at these directions. They want us to find the vector v in the form of ai plus bj, given its magnitude and its angle. Okay, so you got to go back to what we just spoke about, don't you? And to find this vector v, remember, I've got to rearrange this, don't I? If I rearrange this formula over here, v is going to be found by taking the magnitude and multiplying it by u, won't it? Okay, but remember, u could have been rewritten as xi plus yj, right? But since I'm talking unit circle, that means it could have been written as the cosine of the angle for the x, and the y could be rewritten as the sine of the angle. Remember that. Okay, so let's see. What's the cosine of 45 degrees? Excellent. You remember it. Square root of 2 over 2. And for the sine, yep, same thing. Square root of 2 over 2. Which means in this particular case, your vector v, and I'm going to write it here, the vector v would be equal to 7 square root of 2 over 2i plus 7 square root of 2 over 2j. Sorry, ran out of board space, but I'm sure you didn't run out of paper space. Again, if they don't ask for decimals, you can't give them decimals. You have to leave it as 7 square root of 2 over 2. Cool? Okay, this one down here, same thing. They want us to find that vector v given the magnitude and the angle. So, same situation. V is going to be equal to the magnitude of v, which is 16, times u. Well, u could be rewritten as xi plus yj, but remember, since I'm talking unit, I'm talking, I can talk cosine and sine in place. So the cosine of 150 degrees plus the sine of 150 degrees. Okay, 150 degrees is in which quadrant? Excellent, it's in quadrant 2. Do you remember the reference angle? Good, 30 degrees. So I need that cosine. What is it? Cosine of 30 degrees is, did you forget? Okay, hold on. Some of you did. I'm going to erase this little spot over here because some of you need to see it again. And yes, your calc instructors are going to make sure you know how to do this. So there's the 150 degrees, which means that's 30 degrees. There's 60 degrees. That's the 1, right? That's the 2. That's the square root of 3, but this is negative. So what's the cosine of this 150 degrees? Negative square root of 3 over 2 plus, and the sine of 150 degrees? Good, 1/2, which gives me 16i square root of 3 over 2 plus 16j over 2, which means in this case, because these can be reduced, can't they? That vector v would be, good, 8I square root of 3 plus 8J. Now, the authors of the book are going to write the I after the square root of 3. I like writing it before because in case I get too excited and I push the square root out too far, then it's going to look like the I is under the square root. But I'm going to tell you right now, your authors of the book will write it and make it very obvious that the I is not under the square root. Cool? Okay, got a couple more examples. Hang in there. Okay, so let's look at this next set of directions. They want us in this case to find the direction angle of vector v. So they want us to find that alpha, and they gave us a restriction. They said alpha could be between 0 and 360 degrees. I should say 0 degrees, excuse me, and 360 degrees, including the 0 but not the 360 degrees. Now, what I'd like to do for number 1 is I'd like you to look at something. Remember, this is your x and y components, right? So if these are my x, y components, this means my x is 4 and my y is a negative 2, which means I'm here at this point for negative 2, correct? That means, so there's my vector, this means the alpha I'm looking for, remember from the positive side of the x-axis to this vector. This is supposed to be your alpha. And we've got to find that. So, well, how do you find it? Well, you know, here's something that we need to remember. They gave us x and y, didn't they? Couldn't I use a trig function to find the angle knowing x and y? Which trig function could I use? Good, I heard you. Tangent. Because tangent of that angle is going to be y over x, isn't it? And my y is negative 2. My x is 4, which means the tangent of the angle is equal to a negative 1/2. Now, was that negative 1/2 for tangent? Was that like a normal tangent answer? Was that like for a 45-degree angle or a 30-degree or 60-degree angle or even the 90s, the 180, 270 degree, any of those? No, so I have to go to the calculator to find this. So I punched it into the calculator and I made sure my calculator was in degree mode because that's what it's asking for is degree mode. So when I found this, remember, when you find these angles, you're initially finding what's called the reference angle. So when I found it, I rounded it to 2 decimal places and I got a negative 26.57 degrees. So that's my reference angle is a negative 26.57 degrees. Now, understand something. What you just found was this little angle right here. This is a negative 26.57 degrees. But the restriction was not a negative restriction. It had to be positive. So the question is, how do I get alpha? Because I didn't find alpha, I found the reference angle. How do I find alpha? Good. Some of you remember, the reference angle, right, is always from the positive side is always from the x-axis, be it the positive side or the negative side. So in this case, this is going to be 360 degrees. And since it's a negative number, we're minusing the 26.57 degrees. This is how we're actually going to find alpha. And when we do this, we get 333.43 degrees. That is the alpha. And that certainly is a quadrant 4 angle, isn't it? Make sense? When I graphed it, this is actually the x and the y components. It gave me a point, so I knew I was in 4th quadrant. Gratefully, tangent involved y and x. I didn't have to go find r or any of that stuff, gratefully. And when I figured it out, this tangent answer was not a typical one, so I had to go to my calculator. And when I punched it in, I got a negative angle. And this negative angle is that quadrant 4 angle, but the restriction didn't want a negative angle. It wanted a positive angle. Reference angles are from the x-axis. So I took 360 degrees since I was in quadrant 4 and minus the 26 and got this answer for alpha. Good? Okay, so let's see over here on number 2. So same thing, I'm going to draw this so we can see it a little bit better. So my x is a negative 3 root 3 and my y is a positive 3. So that tells me I'm over here at this point, negative 3 root 3 comma positive 3. I'm in second quadrant, aren't I? And this is alpha from the positive side of the x-axis to that vector. Okay. Again, we have x and y, don't we? So, I don't know about you, but yeah, I'm going with tangent again. So to find the tangent of alpha, I'm going to take y and divide it by x. And when I simplify this, I get negative 1 over the square root of 3. Isn't this a typical angle measurement for tangent? It is. So, good. I heard some of you. Reference angle. What's the reference angle? Yeah, the reference angle is a 30-degree reference angle, isn't it? But 30 degrees is quadrant 1. I need quadrant 2. So 180 degrees, isn't it? Which means this is a negative 30 degrees. Right? Okay. Which means alpha is going to be the x-axis angle. Since I'm in quadrant 2, I'm going to take the 180 degrees and I'm going to minus the 30 degrees, which means alpha is a 150 degree angle, which is definitely a quadrant 2 angle. Cool? Okay. Hang in there. We got some models that we're going to, or some stories we're going to model using vectors. So stay tuned.